record what we're doing here so I can post it if people are not here. So the first one, we are like FOIL, first outside, inside, last, but it is like extended FOIL because we got more terms, right? But the idea here is you're going to take this first term and you're going to multiply it times all three, like FOIL. Let me draw our lines. So x times 3x squared is 3x cubed. X times 4x is 4x squared. X times 1 is plus x. Then we do the second term times each one. So that is 1, 2, 3. So negative 2 times 3x squared is negative 6x squared. Negative 2 times 4x is negative 8x. And negative 2 times 1 is negative 2. So there's all of our terms. The next thing we need to do is combine our like terms. So we get 3x squared, or excuse me, 3x cubed. That's another one. We have 2x squared. 4 and negative 6. So that's negative 2x squared. We have two x's. 1x and negative x, 8x. So that's negative 7x. And there's just one number without an x, which is this. Okay. And remember what we were working with here, the name of these are polynomials, right? Many terms. And we always want to write these in the standard form where our exponents go down in order. 3, 2, 1, 0. That's kind of that standard form of how we write. Now, last week we looked at multiplying them, we looked at adding them, we looked at subtracting them, which is just combining like terms, so that's not too bad. The one thing that was maybe completely new was dividing them. Okay? Now, we don't do, when you think division, you think like long division, or long division when you're like in 4th grade, right? We're not going to do it that way. We're going to use something called synthetic division, if you remember. You end up with the same answer. I'm not even going to show you how because the other way is much more complicated. So it's this little trick that we do. And that's what we're going to talk a little bit about today. So if I have x plus 1, I'm dividing by. I want to put the opposite of that in the box. And just like we've done with quadratics and everything else we've done this whole year, if it's x plus 1, the number that goes in the box is negative 1. It's just the opposite. That's no different than what we've done all year long. We now write down all of our coefficients. 1, 4, negative 7, negative 10. Your first step is the 1 just drops straight down. And then if you remember, the number in the box, you always multiply that. So negative 1 times 1. Negative 1, you put that here. And then here, you add. Then you multiply again. Negative 1 times 3. Negative 3. And then straight up and down, you add. Negative 7 plus negative 3 is negative 10. Then you multiply. Negative 1 times negative 10 is 10. And now you add, and you get 0. This number right here, that last number, I'll even kind of put a line there. That number is always, 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 that's your remainder. Now, we write down like what I call our reduced polynomial, or if you want to get all fancy, it's like your quotient. Remember quotient, divisor, dividend, all those fancy words you learned in middle school and elementary school that we don't really use anymore for doing this stuff. But the same idea, we write down our answer, we started with an x cubed. So we drop 1 to an x squared, and this just becomes 1x squared plus 3x minus 10 with the remainder of 0. And there's that. Now, what we want to add to this today, this is a short little addition today, just because we're short on time with our delay today, is when we look at that, if your remainder is 0, what does that mean when you divide? It's factor. It's a factorable thing. So let me show you what I mean by that for a second. Let's go back to, let's deal with numbers for a second. Do a really simple one, right? If I had, let's just pick a number, 18. Is 2 a factor of 18? Yes, right? 1, all of you know the factors of that, right? You can say, well, the factors of are 2 and none, right? So it's a factor. Now, if you, other way would be to actually do long division and say you get a remainder of 0. That shows you it's a factor. So if we have this and we get a remainder of 0, that tells us that x plus 1 is a factor of that polynomial. Give you an example with polynomials before we get to our notes. Something we've looked at before. X squared plus 8x plus 12. And we want to find the factors of that. Well, we've done this a whole bunch, right? 12, 8. What are two numbers that multiply to give us 12, add to give us 8? 6 and 2. So we know that. Now, let's pretend we didn't know that for a second. And I want to take this divide by x plus 2. Is x plus 2 a factor? Yes, we have it right over there. But to show that, if we did synthetic division, x plus 2, I put negative 2 in the box, 1, 8, 12. Coefficients, and now I divide, I drop the 1, I multiply, I add, I multiply. We get a remainder of 0. And what are we left with? We started with x squared, so we drop down 1 and we get 1x, which is our other factor. So we had one factor, there's the other once we divide it out.
And we can do this vice versa as well, with 6 instead of 2.
Correct. It would work the same way. Now, that's if something we know factors. What we want to look at today is, let's say we just say, is something a factor? And so this homework, this is homework, this is notes before we get to the homework. We're going to do the last 3 questions on here. Just because of time, we want to look at these today. And then we'll come back and finish the other ones tomorrow and do some more from there, okay, since we got a shortened class today. So the question is x plus 5 a factor of this polynomial? Now, when it was just like this, we could factor that ourselves and kind of determine it ahead of time. Now that we have this polynomial, we can't look at that and factor it in our head, right? It's not a quadratic. You can't just say two numbers that add to give us this, multiply to give us this. That doesn't work anymore. But we can still determine if it's a factor. So what we're going to do is we're going to divide. And we're going to divide by using synthetic division. So if we're dividing by x plus 5, what number goes in the box? Negative 5. We write down our coefficients. 3, 7, negative 8, negative 5. Let me get to there. So I'm going to do this one, and then the next we can do with everybody here. So we drop the 3 straight down. Negative 5 times 3. Negative 15. 7 plus negative 15 is negative 8. Negative 5 times negative 8 is 40. Now we add negative 8 times negative 8 plus 40, 32. Negative 5 times 32, negative 160. We need a calculator to help us figure this stuff out. That's fine. We get some big numbers. The bells are all off today. They're not on that 2-hour delay schedule. So we get out of here at 10:04. So we got about 10 minutes. So is this a factor? No. No. So our remainder, it is not a factor. The remainder is negative 165. In order to be a factor, your remainder has to be 0. Okay. All right. If you need a calculator, that's fine. I want you to try the bottom one. The bottom one's actually a little easier. So try to do the bottom one. I'm going to come right here with the calculator. And the reason I said a calculator here is you got some big numbers, right? It's hard to take 6 times 39 or 6 times 69 or those big numbers without using a calculator. So somebody need a calculator? Rounded. This way you can. The arithmetic part of it should not be the hard part. Use your calculator to help you out. Probably not 19. 19 is actually harder. I'll go back over and explain why 19 is a little harder. So we're dropping all the way down. Try number 20. Okay. Think, what number goes in the box? What are your coefficients? What number went in the box? 6. And notice when we're doing this, I really don't care what the answer is or the quotient is. All I'm looking at is the remainder. Does the remainder equal 0? Then yes, it's a factor. If the remainder doesn't equal 0, then no, it's not. So we drop 12. I'm gonna get my calculator to help with this. 6 times 12 is 72. Add is 3. 18. 39 plus 18. 57. And you can already see right away, this is not looking good, is it? 372. And so the answer is no. So let's go back and look at the last one here, number 19. This one you got to be careful on. Easy part is we put 2 in the box. Pretty simple there, right? We write down our coefficients. Notice this is the fifth. So I have 6, -8, -6, -4. Here's where we got to be careful. There's no x, and there's no number. So I have to put in zeros. I need 0, 0. Okay? Your coefficients have to go in order. It has to go 3, 2, 1, no x. If you go back, let me go back here, and I look at like the homework from last time. Okay? If you look at this one, this was, let's see if I can make that a little bit bigger so you can see it easier. This was x cubed minus 2x plus 6. There's no x squared there. Skips over it. So I got to put a 0 right there. They have to have all of the terms in order when you do this. So here I have to put 0, 0. Now we drop the 6. Multiply 2 times 6 is 12. Add is 4. Multiply is 8. Add is 2. Multiply is 4. Add is 0. In this case, it works out for us because now we're going to take 2 times 0 is 0. 2 times 0 is 0. And so our remainder is 0. So this is yes. Now, I got this example out of our book. I don't like this example for this reason. This gives you the impression that if you don't put the zeros, it will still work. It doesn't always work out that way, right? It could still, if you don't put the zeros in, it can get you messed up sometimes and not give you the right answer. Okay? So, all we're doing today is just continuing the synthetic division and just determining, is it a factor? This section 5.4 is bigger than this, but we're not going to look at that today.